This is lesson 5.4. So an isosceles triangle, like we discussed, is a triangle with at least two congruent sides. We do have names for the sides that are congruent. They're called legs. So the two congruent sides of the isosceles triangle are called legs, and the non-congruent side is called the base. And then the angles have names as well. So the two angles that touch the base are called the base angles, and the angle that is where the legs meet is the vertex angle. It's important to know the names of the parts of an isosceles triangle because we have some theorems that we're going to use quite a bit to relate those things. So the base angles theorem says if two sides of a triangle are congruent, then the two angles opposite are congruent. So if I knew these two sides of the triangle were congruent, then I could automatically mark these two angles as being the same using the base angles theorem. The base angle is converse. This is our first use of converse when it's not involving parallel, but it is taking the opposite of what we said here. If I started out knowing that two angles were congruent, I can make the sides congruent by the base angles converse. So the base angles theorem, because that's our original, is to say something about angles. It's in the name, the base angles, but the converse is going to do the opposite of that. So that's where we're going to start with the angles and prove something about something else. There is a corollary to this. We probably won't use it in proofs as much, but we will definitely apply it to solving problems, and that is that equilateral triangles are always equiangular and vice versa. So if you have three sides the same, you could automatically make the three angles the same. If you have three angles the same, you can automatically make three sides the same. So in our first example, we have a diagram, and then we have some information. So if I was told that segment HG and segment HK were congruent, which two angles would be congruent to each other? So if these are our two congruent sides, this is my non-congruent side, or the base. So the two angles that touch the base would be the ones that are congruent. So that could be angle G, and then unfortunately I can't call this K, we'll call it angle HKG. The next part, I'm starting with a pair of angles that's congruent. So let's say I had KHJ. KHJ is in the corner here, and KJH is in the corner by J. So if these are my two congruent angles, they're my base angles. HJ would be the base, meaning the remaining two sides of that triangle would be the legs that are congruent, or HK and KJ. So here's a try problem for you of the same idea. Pause if you'd like. The answer is posted online. All right, example 2, find the value of the variables. So I have a triangle here that is equiangular, which automatically makes it equilateral as well, because we talked about that. So I could solve for y right now because 4y is equal to 28. So y equals 7. The other triangle, we're going to have to do a little more work. Since this is 28 and this is 28, these two segments are congruent, which also means these two segments are congruent. So this other triangle is actually isosceles. So that would make this the base because these are the two legs, making these two angles the same. So that's also 2x. And every equiangular triangle is automatically 60, 60, 60 because 180 divided by 3 is always 60. So I can use the exterior angle theorem here from section 5.1 and 5.2, where the sum of the two non-adjacent interior angles is equal to the exterior angle. So that's 4x equals 60 and x equals 15. All right, here's a try. Pause if you'd like. Answers are posted online. All right, here's example 3. Again, I do see I have an equilateral triangle, so this x automatically would be 60 because it's going to be 60, 60, 60. Don't even have to do work for that one. And I'm going to place a 60 here because if this whole thing was a right angle, that automatically makes this other part 30 degrees. And if this triangle is isosceles, based on these markings here, these base angles are both 30. So now I have 30 plus 30 plus y. and that will equal 180 using the triangle sum theorem. So that's y plus 60 equals 180. Take away our 60, y equals 120. Example 4. I do have an isosceles triangle and I have an exterior angle. But the exterior angle is a y and everything else is x, so I'm going to save that for the very end. So with this isosceles triangle, here are my two legs, making this the base and these the base angles. So there is another x minus 2 in this corner. So I could take the three angles of this triangle and use the triangle sum theorem to add them to 180. So that's 4x, 5x, 6x, 10, 8 plus 6 equals 180. See if my mental math is okay today. 6 into 174 is 29. I'm hoping that's okay, and I'm actually going to check it for us. 174 divided by 6 is in fact 29. So if x is 29, this angle over here is 29 minus 2, or 27. And this is a linear pair. So 3y plus 27 equals 180. So 3y equals 153. And y equals 51. Here's try 4. Pause if you'd like. Answers are posted online. And now we get to a proof. So we are given that segment BD is parallel to segment CE and that angle 5 is congruent to angle 6. I'm going to start by only using that first given. You could use it all if you want to start. I'm going to use what I can actually apply first, because there's something I know I can do with the fact that I have parallel lines. I know every time there's parallel lines, there are congruent or supplementary angles based on that relationship. And if this line here is parallel to this line here with a common transversal, then I can actually say 5 is congruent to C, because those are corresponding angles. So I'm going to say angle 5 is congruent to angle C. I'm calling it angle C because before I drew those lines there was only one angle at C. So that is the corresponding angle postulate. Postulate because it's about the angles and it's not about proving lines parallel. Now I'm going to throw my other given in. I could do more with the lines are parallel, but I'm going to hold on for a second. I'm going to put my other given, and now I have two different statements with an angle 5 in them. So I can link them together and just say that angle C is congruent to angle 6. And you know, when you link together, we're really using the transitive property. I'm going to actually go back now to my parallel lines, because just like I used the transversal on this side, I could be using the transversal on this side with my parallel lines. And I could say that angle 6 is congruent to angle E. And that's, again, corresponding angles, so it's the corresponding angle postulate. And now steps 4 and 5 both have an angle 6 in them, so I can link them together and say that angle C is congruent to angle E. And that's transitive property. So my last step, I'm proving that segment AC is congruent to segment AE. If I know that the base angles here are congruent, that would make the legs here congruent of the big triangle. So I can say that segment AC is congruent to segment AE, and that is the base angles. And now let's think about it. Is it about angles? No, so it's going to be the converse. Remember, we use theorem if it's about angles. And that's our proof. There is one more proof for you to try. All the statements are given. So if you want to pause and fill it out, the answers are posted online. But that is the end of section 5.4.